So we just walked through this example right here where I had x double prime minus 3x prime plus 2x equals t squared. I took an xp of at squared plus bt plus c. So I'm going to talk a little bit about what to do with different inputs or forces on this right-hand side. So let's take the same thing. It is x double prime minus 3x prime plus 2x equals, say I had t to the fifth, what would it look like, right? Well, you need to go until, this is the judicious guessing part of it, you need to take functions that are derivatives of that thing and that thing all the way down until it either A, repeats, or B, goes away. So this one would have a lot of pieces. I would have a t to the fifth, this is xp, the xc would stay the same, plus b t to the fourth, plus c t cubed, plus d t squared, plus e t plus f. So you can imagine that would take a lot of work, and this is one where I would definitely want to be using a system of equations. Say instead, so let's just look at what is here, right? Say instead of a t to the fifth, I had a sine of 5t, right? Well, in that case, I would let my xp be equal to, all right, well, sine of 5t derives to cosine of 5t, right? And then that derives to a negative sign, right? With some coefficients out front, but I don't really care about the coefficients. I just care about the functions. So this would just have an a and a b. A sine of 5t plus b cosine of 5t. And then I would go through and plug it in the same way we did with the previous ones. So let's look at one more. Say instead of t to the fifth, I had 1 over t. That would be a problem. Why is that? Imagine taking the derivative of 1 over t until it A, repeats, back to a function it's already been, doesn't matter what the coefficient is, or B, goes away. Those two things, they don't happen. 1 over t. Next thing would be something 1 over t squared. Next would be something over t cubed, and then blah, blah, blah. It would keep going for forever, right? So this method fails if I've got a function that doesn't go away or repeat. So keeping that in mind, we are going to do one more. Let's take x double prime. We'll do plus 3x prime plus 2x equals 10 sine t. All right, so first thing you got to do is find the xc. So I would get r squared plus 3r plus 2 equals 0. R plus 1, r plus 2 equals 0. That gives me my xc is equal to c1 e to the negative t plus c2 e to the negative 2t. So now I do my xp. xp is equal to, all right, I'm going to have an a, sine of t. I don't need to include the 10 here. I can just do the a, and it'll spit out the 10 because I'm going to set up the equation to make it do that, plus b cosine t. That gives me xp prime is, all right, I got a positive a cosine t, and then a minus b sine t. And then I got to do double prime. xp double prime is equal to, all right, here I'm going to get a negative a, oops, not a cosine, sine t, minus, it will still be negative, b cosine t. Now I'm going to plug these guys in this, whoops, this right here is going to go in there. This right here is going to go in there. And then this goes here. So that gives me All right, so minus a sine t minus b cosine t, and then plus, all right, I got 3. I'm going to distribute right away. So 3a cosine t minus 3b sine t, is that right? Yep. Plus 2, let's see if I can fit it, a sine t plus 2b sine, sorry, b cosine t equals 10 sine t. So now I got to split it into sines and cosines, right? So this, and what else do we have? A sine, here's a sine next to our cosines, and here's a sine. They're going to come together to be a 10 sine t. And then this and this and this, there are no cosine terms over there, so I put a 0 on the right-hand side. So let's do that. I get negative a sine t minus 3b sine t plus 2a sine t equals sine t. And then, or sorry, 10 sine t. And then that's my first line, and then I will get another line that is, all right, minus, come on, minus b cosine t plus 3a cosine t, and then plus 2b cosine t equals 0 cosine t. And now this is like already set up as my system of equations, right? And look, I got some common terms here. Sine, I actually have 1a. Is that right? Yep. So this negative a adds with that. And look, from this line, from here down to the next line, I'm also going to divide by sine t in this first equation. So I'm just going to have minus a, and then positive a minus 3b equals 10. And then my next line, I'll divide by cosines. And let's see, I've got minus b plus 2b. So is that 1b? So I get b. How many a's? 3 a's. Are they both positive? Yep. Equals 0. Now I'm going to go and use the matrix 1, negative, 3, bar, 10, and 3, 1, 0. You could totally solve this by hand, but I find it tedious, and I'm fine with you using a calculator to solve it anytime you come to one like this. And what do we get? We get a equals 1. Oops. And we get b equals 3. I'm going to check that real quick. Checked it. It's negative 3. So what's that mean? Well, if you remember, this here, this line, was the xp. So the a and the b go in there, right? So my xp is equal to 1 times sine t minus 3 cosine t, right? And then my xc, I've already got it listed here, You could write x of t is xc plus xp, since we've already defined them, or if you want to write x of t is c1 e to the negative t plus c2 e to the negative 2t plus sine t minus 3 cosine t. And that's a little bit more of a complete answer, but I would take either one. So hopefully you see this and you're ready to go try some when we see each other next.